Well, no, you could have DMV.
Is there a rate at which I have to derive at?
Can you derive a different rates on different equations?
Yes.
Let's talk about the rates in which parametric curves are changing.
Speed limit on
That is stupid. What is it?
it's 35 now.
Oh, man.
That is smart.
The speed limit where?
Dumb.
On straight, like if you go on straight, everyone goes like about 55 and it's a 35.
Okay, before we lose all control, let's focus on parametric equations. Okay? Now, yesterday we found dx dt and dy dt to determine when a curve was not smooth. If we want dy dx, then we can simply take dy dt, dx dt. Because the dt's cancel and we are left with dy dx. See that happening?
Wow.
It smells better. From O to A to E.
Smooth. Yep.
Looking at it there, do we ever have to do a calculus proof?
What?
Would we ever need to do a calculus proof?
Like for this?
No, just in general, because I just looked at the I'm just curious.
Oh, I mean, there are things that I will show you the proof for, but I'm never gonna ask you to get that is true.
Yeah. So in here we do not have to. Would we theoretically have to?
Sorry,
Yeah.
Britain.
Like, are there classes where they ask for calculus proof?
In calculus, you're gonna focus on the computation. After calculus 3, you need to get into the proofs. I basically took a class of calculus proofs called, well, was it, yeah, it was, well, proving a bunch of things.
That sounds good. I heard there was like a college class and all they were doing is learning how to do a proof for 1 plus 1. You need to go into some theoretical math to like get like the solution that 1 plus 1 equals 2.
Yep.
That was something awesome. No,
I should look up some of my stuff. I have all my notebooks from college. I should show you. Okay, so here's an example. Find the equation of the tangent line to this set of parametric equations at t equals 2. Okay, so we have a set of parametric equations, but we know that that creates one curve on the xy plane. Okay, well, if we want the slope at a point, we need to be able to calculate dy dx, which is the method you just wrote down on the orange slide. Okay, and if we can find slope, then we know we can find the equation of a tangent line. Okay, it's just going to be a little different parametrically because our curve is defined in a different way. Okay, now, are you pretty glad that you're not having to eliminate the perimeter here? Okay, it's going to be way messier to try to eliminate the parameter in graph. Like, we want to graph this as a parametric curve, which means we're going to have to find the derivative parametrically. So, dy dx is, what is the derivative of y with respect to t?
16.
X with respect to t. Okay, dy dx, derivative of y divided by derivative of x.
Isn't that just 55?
Isn't that just what?
60 minus 5. Right?
Yeah, I get it.
What do we need to do if we're going to write the equation of the tangent line at t equals 2? Okay, we need to have our slope evaluated at t equals 2.
Okay.
What? Jake, what did you say? Okay. Grayson said 19/4. I asked you. Now what?
I got counted on from the class for that.
How do we write the equation of the tangent line? We have slope, now we need a point. 2 is not our point, is it? How do we find our point? Plug 2 in for x and y. So x of 2 would be 2 squared plus 1. And y evaluated at 2 would be 2 times 2 cubed plus 5 minus. Which would be
Multiplied by,
Oh, wait, is it okay?
I did 11 at first too.
so our coordinate is 5, 6. So the equation of our tangent line would be y minus 6 equals 19/4 times x minus.
And that's all we're doing today.
Well, it doesn't get.
now our homework.
Write down the set of parametric equations, please.
And
240.
on Friday,
See that 240?
since I won't be here,
40 squared,
I just lived online, so that's stuff.
You see the 240 at the end?
Okay, if we want a horizontal tangent line, we want dy dx to equal 0. What are we really focusing on if we have a parametric equation? Our numerator is dy dt. So this is essentially asking for where dy dt equals 0. Okay?
We have to look at the dx to make sure it's not 0 at the same time.
Oh, okay. That is true. Because if there's 0 simultaneously, what does that mean?
The hospital.
No.
No, then it's not smooth.
Well, it's the same.
Not smooth.
It's not smooth. It's not well, technically yes, it's undefined. It's not smooth. Okay?
Why do we care for something smooth?
Yeah, what's the purpose of smoothness?
Basically here. Okay? What is our dy dt?
Not smooth.
60 minus 24, right?
Yeah.
Okay?
60 squared.
Oh, sorry. And if we're looking at where this is 0,
3,600.
then we get t equals plus or minus 2. Now, if either of those t values makes dx dt 0, it's not smooth, which means we don't have a horizontal tangent line. So
We don't have to worry
what? Okay, dx dt, and you don't technically need to like show the work, right? But you need to consider it. Dx dt would be 2t plus 6. Does 2 or negative 2 make dx dt 0?
No.
It doesn't. So we don't have to worry about this curve being not smooth. We have horizontal tangent lines when t is plus or minus 2. Now I'm asking for the points in which we have horizontal tangent lines. Is our point 2 and negative 2?
No.
When t equals 2, what is x?
At 2.
Yep. And y? Are you?
So the 240 just goes away.
32.
What?
Oh wait, yeah. So you subtract 240.
What are you talking about?
Ignore him. 240. Just ignore him.
Like I am legitimately confused.
240. 240.
Or you could say 2040.
When t is negative 2, what is our x value?
Come on, it's 2017. Open your minds.
When t is negative 2, what is x?
Negative 8, yeah.
And what is y?
8. Wait.
Uh,
I think it's 8.
No.
So negative 16.
It's 16.
Plus 48. 32.
You were close, yes. Okay. Along those same lines, where is this curve? Where does this curve have vertical tangents? So this is the same curve, correct?
Same lines.
Okay.
Nice.
So when we talk about vertical tangent lines, we talk about where dy dx is undefined, right? And so specifically with a parametric equation, or a set of parametric equations, what are we looking for?
Dx.
Okay, we want dx dt to equal 0. Okay, well, let's first find dx dt, please. Dx dt would be?
2t plus 6.
That doesn't really work with your little pattern there, does it? Okay, so where is it 0? Okay, does that answer the question?
Nope.
Point.
Negative 3 is minus 18.
Okay, it's asking for the points, or in this case, point, where we have a vertical tangent. When t is negative 3, we plug that in for our x equation, and we get negative 9. And for y?
Yeah, I can't.
You were doing all of this.
That's negative 13.
But
That's
those are like
negative 4
memorized.
minus.
Negative 18.
That's 24.
Isn't it positive?
It would be positive.
Positive makes more sense.
Hello, Mrs. Herndon. You're going to be quiet.
16, 12, 17, 17.
Okay, are you ready for this? Is anybody curious about a second derivative with a parametric equation?
No one is clear.
Okay, now here's the deal. If we were to, typically when we take the derivative of dy dx, that's how we get our second derivative, right? We just take the derivative with respect to x. Now, our derivative is going to be in terms of which variable?
X.
No, T.
It's gonna be in terms of t, right? dy dt over dx dt. So when we go to take the second derivative, we can't just take the next derivative with respect to x, because our derivative is not in terms of x. So what we have to do is we have to take the derivative of dy dx with respect to t, and then divide by the derivative of x with respect to t. Write it down, we'll process it again. There were two girls that came up to me that signed up for the 28th building and can't do it anymore. So I told them to email me so that we could have them in there some time so we can find somebody. Or they can find somebody else. Because we need some of it to find somebody. Okay, it was like 18.
Yeah, because I already gave it to her. She already has them signed and their names in the thing. Okay, so they need to find some people that do that. I got off, I'll email that today. I'll look and see, we might have had. I'll look and see, but yeah, they need to find somebody.
What time do we need to do this tonight?
What?
What time do we need to do this tonight?
Was it 6?
6?
Okay. So typically we have a derivative in terms of x, and we can just take that derivative with respect to x. So what we have to do is we have to take our derivative with respect to t, but we want the second derivative, d squared y dx squared, right? So since we're taking the derivative of this, but only with respect to t, we have to take the derivative of x with respect to t to divide it by. Okay? Are you following with why that?
I've seen an example in problem today.
I don't know. I imagine it's the same as the reason why magnet through a copper pipe creates a special difference.
Oh, the DTs cancel because you have a CT, and the DTs you cancel, you have a D. Or no, they don't
In the
cancel.
words of Marsh, I don't know
Am I
why.
confused? Oh.
It just is.
GT's cancel.
Yeah, the T cancel, but it's the X squared.
No, it doesn't.
No, they don't.
No, they don't cancel because it would be.
It's still on the bottom.
We have
T
we give them
squared.
T's.
And then these,
So it's just
The
But then-
DTs do cancel.
Oh.
And then you like with the derivative of dy
Well,
dx.
you already you get the
And then you
D's.
get
Then you
the
get
DTs
the
with Y. Yeah.
I see it. I see it.
Yeah.
Oh wait, no, never mind.
You did
Oh,
this
so
song that's like
wrong.
outbreak.
Read.
Okay.
So why is there like a D string words? I never understood that.
What?
So when you do your second derivative, why is it d squared y and then dx squared instead of y squared?
Because you're taking the derivative twice with the respect to x. Yes.
How did they stumble upon that equation?
This looks fun.
What do they do? What do they do to the derivative?
I feel like
I
I think it was
where
an
they're coming
accident
from,
that they found this equation.
but like, I don't understand.
I mean, it's really more about algebra to understand why that works. What you agree?
I understand.
Okay, so I guess I'm confused with your question.
So how do they get dy over dx? They get it from dy dx equals dy over dt. It was the dt to that. What did they do when they derived that?
Okay, maybe this would,
For newly.
Multiply by the reciprocal and it all works.
Makes sense now.
definition of the second
That's the
derivative.
most annoying ways.
Yeah.
Okay, if you wanted to do the third derivative, it would look the same, except this would be second derivative up here. But since our derivatives are going to be in terms of t, we have to divide by dx dt to account for that dy dx. But in terms of t, we have to divide by that dx dt. Does that help with your question? Here. Does that help with your question?
Yes.
Okay. Okay. All right. So I want to know if this function is concave up or concave down at 0, 4. Which means we need to find the second derivative, right? So let's first find the first derivative. I'll let you get it written down first, sorry. Take a drink of water. What is dy dt?
3t squared minus 2t over 2t minus 2.
Okay, can we simplify that at all? No chance. So, when we go to find the second derivative, we need to take the derivative of dy dx with respect to t and then divide it by dx dt. So for sure we have to divide by dx dt.
We were talking about this today.
And our numerator is the derivative of this lovely quotient.
You can always avoid the quotient.
Okay? So quotient rule. We have 6t minus 2 times the denominator minus 3t squared minus 2t times the derivative of the denominator, which is 2, all over 2t minus 2 squared. Now here's what is nice. If you do have to use the quotient rule, which could be often because we are talking about a fraction for our derivative, okay, what's going to happen with your quotient rule? Right?
That one cancels.
Well, they will not cancel.
Oh, okay, that's gonna be good.
They'll combine.
That's cute. You gotta think. Come on.
Wait.
They combine to be 2t minus 2 cubed. Okay? So then our numerator,
One of them cancels.
we have 12t squared minus 12t minus 4t plus 4. And then we're subtracting. I'm going to go ahead and distribute that subtraction through. So we have minus 6t squared plus 4t. Do you agree?
Yeah.
That looks simple.
Okay. So our second derivative is 6t squared minus 12t plus 4.
Are you gonna show us a quick tip after this?
Hmm? After this, we're done.
Okay.
Do we have to use our calculator
Yeah.
next semester?
In this class.
What was I asking for in the very beginning?
Concavity.
Concavity at 0, 4. Okay, so let's go back up to this. 0, 4. Well, my second derivative is in terms of t. So we need to figure out what t value gives us 0, 4.
So shouldn't I just set one of the equals so like that?
So I think the easiest one would be to put 0 in for x.
T equals 0.
So either t equals 0, is that the case? Or t equals 2, is that the case?
Um,
2 cubed minus 2 squared would be 4, wouldn't it? Okay, so t equals 2 is when this occurs. So we are going to come down here,
so,
and we are going to evaluate our second derivative.
Did you figure that out just by like guessing jump?
conjugate up.
Well, what we did just there was algebra.
You can do this, or you can.
You could do guess and check, but what I did is we knew that x needed to be 0. So we put 0 in for x. Well, that happens at either t is 0 or t is 2. Well, 0 doesn't make sense because y would be 0. That's not what we want. But when t is 2, then y is 4, so that is what we want. Does that make sense, Jake?
Yeah.
All right, so when we plug in 2,
So if it's 0% chance. Just guess. So odds are hard to pass that off.
Concave up. 1/2.
So if you just guess.
we get 1/2, which is positive.
Yay.
Yeah?
At what point do that number just turn into 3?
Huh, never.
I like how you still got the same number.
Excuse me, we're still in class.
Voice
Then you can check it later.
United States.
I don't know. United States.
Probably asking about
I have 4
You want
parametric
to revise
equations.
on-
Actually, I have more than 4. Okay. Well, let's just say I have 4 parametric equations. I am going to give each group a parametric equation. And I want you